Okay, guys, this is section 8.2, part 2. I may do it in two parts again, but they should add up to be no more than 50 minutes. So this would be part A. I'll let you know for sure at the end, but more than likely two sections works out better. And I'm going to start dating it, so this is for April 6th. Depending when you get to it, you might get to it early, you might get to it late, but the date that it's for, so you can kind of keep track, is April 6th. Okay, this here is a review. This was what we did in part 1, 8.2 part 1. We did the harmonic series, the geometric series, and the test for divergence, okay? Now today we're going to add one more piece to that, but I just thought I would kind of keep track. Remember, 8.1 dealt with sequences, which was great, but now from now on we're going to be dealing with series. So these are the first three kind of tests that we have for series, okay? All right, so I want to look, before we get to our fourth one, we're only going to do one today, and then we're going to do something else. We're actually going to come back to geometric at the end of this 8.2 part 2. Okay, let's take a look though at this problem. The summation from, and notice we're going to start at 2 to infinity. What they say is, hey guys, we're going to infinity. It doesn't really matter where we start. Sometimes we have to start at 0, 1, 2. You know, the first few, it just doesn't have a huge impact since we're headed to infinity. 2 over n squared minus 1. Okay. So now if we kind of go through our things, it's not harmonic. Harmonic has to be like 1 over n. That's what it has to be. Or somehow simplify it to that. Geometric, the n has to be an exponent. So really our only option would be test for divergence. Okay, and if you just want to watch, you can. Let's try this test for divergence. Remember, it's very important that you're going to write down, especially for the test, what you're using. Okay, now this part you can just watch if you want. So the test for divergence, we can't do L'Hopital's rule because we don't have, remember, well, actually, let's back up. What a test for divergence says, it is okay to do the limit as n approaches infinity and to just look at the sequence. Don't worry about the summation. Actually, just look at the sequence. All right, and test for divergence, we either did L'Hopital's rule, but remember, his has to be infinity over infinity, or every once in a while it's 0 over 0. But we don't have infinity in the numerator. So then our only option is to divide everything by n squared, whatever's in the denominator, the highest exponent limit in the denominator. So this is 2 over n squared divided by n squared over n squared minus 1 over n squared. Okay. All right, so what happens? The limit as n approaches infinity, this is going to stay. This will at least go to 1, and then this is going to stay. Okay, and what happens when I put then bigger and bigger numbers in? 2 divided by a really big number is 0. Okay, 1 over 1, or well, that's 1. We already simplified that. And then I put really big numbers in there. 1 divided by a really big number is headed towards 0. So we get 0 over 1, which equals 0. And what's the bad part about that? The test for divergence, remember, if the limit equals 0, no conclusion can be made. So, and that's going to happen sometimes. I'll try to steer you in the right direction all the time, but I just wanted you to see out of our 3 choices, this was the only applicable one, and that one didn't even work. Because if I get an answer of 0, it tells me absolutely nothing. Okay, so today we're going to learn what's called, it's very isolated. You don't use it a whole lot, so don't completely panic. But I just want you to see like all the options out there at least. It's called the telescoping sum. Telescoping sum. Okay, and we'll talk about why it's called telescoping. And so a great one to apply it on is this one, n equals 2 to infinity. And then 2 over n squared minus 1. Okay, so we're kind of, instead of writing down like a rule, we're just going to go through some examples. That's the easiest way to do the telescoping sum. But guess what? The first thing we need to do is we need to do partial fractions. Okay, so we have to do partial fractions. Okay, so that is when we did 2 over and we factored this. This factored to n plus 1 and n minus 1, right? That factors, and we set it equal to a over n plus 1 plus b over n minus 1. Okay, remember this? And we did partial fractions to take the integral of each. Okay, well, we're going to now do partial fractions to help with the telescoping. We'll get to why it's called telescoping in a minute. Let's see, let me grab a pen, different color. So we're going to multiply everything by n plus 1 and n minus 1. N plus 1, n minus 1. One more time, n plus 1 and n, minus 1. Oh dear. Okay. All right, so what happens here? The both cancel, right? All that cancels, so we got 2 equals, the plus 1 cancels here, so we have a n minus 1, and then let's see, I kind of messed up here. This is n minus 1, right? So we have plus b n plus 1, okay? All right, and then remember what makes this 0? We want this to drop out, so what happens when n equals 1? When n equals 1, we get 2 equals, we plug in the 1, that goes away. B, we plug in a 1, we get 2. Okay, divide both sides by 2, and 1, B is 1. Okay, so we hang on to that guy. We do it all over again. What's going to make this 0? Negative 1. Slide that down. All right, so we got 2 equals a, we need the a, right? Because when we plug in a negative 1, we get negative 2. Here, when we plug in a negative 1, goes to 0, so we don't need that guy. Good. Divide by negative 2, and negative 1 equals a. All right. So what does that mean? Instead of writing this, I showed that it could equal this. Do I have enough room? Okay. The summation n equals 2 to infinity. And then a is negative 1, so negative 1 over n plus 1. And then plus b, which is 1 over n minus 1. So this and this, same thing. Okay, if we took the time to get a common denominator and put it all together, it would be this guy. Okay. Since this one's negative, I'm going to take the time to rewrite it. Let's rewrite it. N equals 2 to infinity. We're going to do 1 over n minus 1, and then minus 1 over n plus 1. Okay. Okay, so now what we're actually going to do is we're going to actually create the actual sequence. Let's take a look. I'm going to slide this up. Let's take a look at what the sequence would actually look like. So let's actually plug in a 2. If I plugged in a 2, I would have 1 over 1. Okay, minus, if I plug it in a 2, I would have 1/3. Okay, then the summation says, I could even do plus. Okay, this plus is just coming from, hey, this is my summation, right? So now I plug in a 3. When I plug in a 3, I would have 1/2. I plug in a, what am I plugging in? Wait, I'm plugging in 3, right? Okay, so I'd have minus 1/4, right? Okay. Actually, let's write that. So this was when I plugged in a 2. This is when I plugged in a 3. Okay, let's do plus. This is going to be when I plug in a, maybe we'll write it, plugged in a 4, right? When I plug in a 4, what do I get? So I plug in a 4, I get 1/3. When I plug in a 4, I get minus 1/5. Okay. Plus, now I'm going to plug in, let's see how much room, maybe I should have written a little smaller. Can we see? Okay, yeah, we can see. Okay, I'm going to plug in a 5. Okay, when I plug in a 5, I get 1/4. When I plug in a 5, I get minus 1/6. Okay, plus, now I'm going to plug in a 1/3. When I plug in a 1/3, I get minus 1/5. Okay. Okay, when I plug in a 5, I get 1/4. When I plug in a 5, I get 1/4. When I plug in a 5, I get minus 1/6. Okay, Okay, we're doing okay. Let's at least do one more. Let's do 6. 6, so when I plug in a 6, I get 1/5. And then when I plug in a 6, I get minus 1/7. Let's go one more. We can fit it in. Let's write kind of small. I actually probably could. That's all right. All right. Oh, we're plugging in a 7. Let's keep all the colors good. So when I plug in a 7, I get 1/6. And then minus, when I plug in a 7, I get 1/8. Okay. Now we know it's dot, 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 right? It keeps going on. Okay. All right. Let's see what happens, though. See how this is negative 1/3 and this is positive 1/3. So these two are going to cross out. No matter how far I take this out, those two are gone. Negative 1/4, positive 1/4. Those are gone. Negative 1/5, positive 1/5. Those are gone. Negative 1/6, positive 1/6. No matter how far I take those out, those are gone. And that's why, notice like here, this is gone, this is gone. If we kept going out, then this would be gone. That's why they call it telescoping, because you only have kind of the beginning and the end. Everything in the middle goes together like a telescope, or technically kind of gets crossed out. Okay. Okay. So we got to figure out what we have left. So we have this 1. We have this 1/2. Gone, 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 gone. Now, if I keep taking it out, this one would be eventually gone. They would be eventually gone. But this last one is 1 over n minus 1. Okay. And this one is 1 less than that. So this is my second one again. So that's this guy. So my negative 1/7 is 1 over, oh no, oh dear. I should be taking it from here, right? Hang on, guys. I should be taking it from here because this is my second one. So this should be negative. Okay, good. We can actually fix that. That should be that guy. That actually looks better. This negative 1/8 came from here, right? Get out of there. These two are the same, but then this is a better version of that, right? Okay, so my second term is this guy. My second term is still alive. And so that's this guy, but 1 less. So it would be negative 1. The negative's coming from here. Negative n plus 1, but it's 1 less. Because this is technically like my last term, and then this is 1 less than that. So I would have, now how does this simplify? Well, the plus 1 and the negative 1 cancel, right? So I have negative 1 over n. And then I have this guy, minus 1 over n plus 1. Okay, and then we're taking the limit as n approaches infinity. Okay, but what's going to happen to these guys? As I put in a bigger and bigger number, this is headed towards 0. Same with this guy. This guy's headed towards 0. So this is 0, this is 0, 1 plus 1/2. So it is 3/2. Okay. So if we add all of these up, it's going to approach 3/2. Okay. Okay, let's try another one. Okay, let's bring this back down. Let's do the summation. This one's going to start at 1, from 1 to infinity, okay, of 3 over n times n plus 3. Okay, so again, out of our rules, or I forget what do they call them? Tests, rules tests, whatever. The only one that we could maybe try is the test for divergence, but I think we get a 0, which means it tells us nothing. Okay, but now we have a new one, and that is the telescoping. So we're going to write that we're going to use telescoping. And why is it called telescoping? The telescoping sum, because all those middle terms drop out. So it's like the n's Push them together, that's all you care about. You know how a telescope, you push it together and you only see the first and the last. Okay. All right, so that means what are we going to do? First thing when you do telescoping is you have to do partial sums. Partial sums. So we're going to do 3 over n times n plus 3 equals a over n plus b over n plus 3. Okay, so first thing we got to do, multiply everything by n times n plus 3. So we're using a little bit from chapter 7. Not the integral stuff, but the other, things that go with it. So those cancel nicely. We get 3. Here the n's cancel, so we have a n plus 3. And here n plus 3 cancels, so we've got b times n. Okay. All right, so what's going to make this 0? So this drops out. We're going to let n equal negative 3. Okay, so we've got 3 equals, this guy goes away. So we got b times negative 3. Okay, divide by negative 3. And negative 1 is b. They keep them pretty simple for us, so just so that we kind of get the idea down. Here, what's going to make this 0 is 0, right? So we're going to plug in a 0. So we've got 3 equals. We plug in a 0. Here we've got a. Are we okay if we just write 3? The 0 goes in there, so we'll just write 3. And then when the 0 goes in here, whole term drops out. Divide both sides by 3. And so a is 1. Okay, so how can we rewrite this guy? We can rewrite it as 1 to infinity. This one happens to be starting at 1, so just kind of take note of that. A was 1, so 1 over n. And then minus, do we want minus? Yeah, b's a negative 1, so let's write it like this. Plus negative 1 over n plus 3. Okay, but we can change that. Let's go ahead and change that. N equals 1 to infinity, 1 over n. Let's change it to minus, and then 1 over n plus 3. You don't have to, but sometimes it's nicer to look like that. Okay, so how are we doing? So now we're going to actually write some stuff out. Okay, so let's write out when it's 1. What is that going to look like? We'll plug in a 1, and so we get 1. We plug in a 1 there, we get minus 1/4. Okay, I probably should have started over a little bit, but that's okay. Oh, shoot. That's supposed to be this color. That's what I get for doing 2 colors. All right, plus, now let's do a 2. All right, so we plug in a 2. Okay, so let's get enough so that you can start seeing what cancels. So negative 1/4 doesn't cancel until here, but that's okay. What else cancels? 1/5 cancels. I don't think this guy cancels either, but now, so maybe we needed to take it out that far. How are we doing that? Can we see? So 1/3 does not cancel. The negative 1/6 cancels, and now you can at least see that the negative 1/7. You kind of want to get to a place where both cancel so that you can kind of see like, okay, the 6 canceled Oh, we can even start here. The 5 canceled, the 6 canceled, the 7 canceled. So to guess what's going to cancel, if we wrote out another one, the 8th would cancel, the 9th would cancel, and so on. Okay. I wonder if I should even do another color. Okay, so what is this guy's rule? The negative 1/10 is coming right from here. So this guy is negative 1 over n plus 3. Okay. This one also doesn't cancel. So this one is coming from the second. It's out of the 2, it's the second. So it would be negative 1 over n plus 3, but then minus 1, because it's 1 in from the last. And this guy, right? This guy. So this guy's the second out of those two. So it would still be the negative 1 over, it would be what? N plus 3, because it's coming from the second one, but then minus 2, because it's 2 in. Okay. Okay, and so now we want to do the limit as n approaches infinity of 1, that's never going to cancel, 1/2, that's never going to cancel, and 1/3. Okay, and then let's see if this makes sense. You're going to say, well, eventually isn't this one going to cancel? But if this one cancels, then I would have negative 1/9, negative 1/10, and negative 1/11. So these 3 are always hanging in the balance. Notice that n changes. So yeah, as it keeps going out, but kind of like when I push my telescope together, these 3 would be hanging around and these 3 would be hanging around. Notice these aren't numbers because yes, it is increasing, but these 3 would be hanging around wherever the end is. Okay, so see if that helps at all. So I've got negative, maybe I'll do those in blue. These would be what? Negative. This would go to n plus 1, right? 3 minus 2, so 1 over n plus 1. This would be negative 1 over n plus 2. And then this one would be negative 1 over n plus 3. Okay. All right, but what happens as we take the limit, as we get these bigger and bigger, as our denominators get bigger, they're headed to 0. So our answer is actually 1 plus 1/2 plus 1/3. And then just grab a calculator, common denominator would be what? 6. 6, 7, 8, 9, 10, 11. So 11, 6. Okay. Okay, let's do just 2 variations of this. Okay. All right. Let's try this guy. Oh, wait, should we? Oh, no. Okay, yeah, let's do this guy. All right, let's slide it down so we can see. That'd be helpful. Summation, n equals 1 to infinity. We're going to do the natural log of n over n plus 1. Okay, but 1 log of division is 2 logs of subtraction, which is really what we need to do this telescoping. We really need 2 terms, and we really need to be subtracting them. All right, so we've got, 1 log of division, 2 logs of subtraction. Okay. That's kind of the format that you want if you're going to be trying this telescoping. Okay. Okay, so I think, I'm trying to think if there's anything else I was going to say. I think we're ready to plug stuff in. So let's plug in a 1. Yeah. I think there's too much room here. So if we plug in, okay, here we go with the colors. If we plug in a 1, we get ln of 1 minus, if I plug in a 1, ln of 2. Okay, and then plus. Now, where's this plus coming from? Remember, we're doing sigma, which means the addition. So add, now I put in a 2. Don't change colors. All right, let's do 2. ln of 2 minus ln of 3. Okay. Plus, that's coming from the sigma. Let's do 3. So I do ln of 3 minus ln of 4. And then let's at least do 4. I think that might be enough. If I plug in 4, I get ln of 4 minus ln of 5. Okay. Okay, so does anything cancel here? What shrinks down in the middle, that telescoping idea? Then, oh dear, what was this supposed to say? This should say ln of 2. That looks better. Okay. Yeah, that actually, okay, yeah, that, yeah, make sure that you write that down. That should be ln of 2. Hopefully I said that. And look, that actually cancels right away. Then -3, +3, -4, +4. Okay, so yes, my 5 would cancel, but then I'd have this one hanging around, right? If, wherever kind of like I stop, so to speak, even though I'm headed towards infinity, I always have, this one's kind of nice. You can actually see these kind of all drop out. I have the first and the last. Okay, so I'm doing the limit as n approaches infinity, and I have ln of 1, and then I've got minus. Now, I don't really have ln of 5. I have wherever I would technically stop, which would come from back here. So minus ln of n plus 1. Okay. All right, let's go back to green. All right, so what is ln of 1? ln of 1 is 0. So I got the limit as n approaches infinity. That guy is 0. But what happens here? I am taking the limit, and I am getting bigger and bigger numbers. And so as this gets bigger and bigger and bigger, this is just going to get bigger and bigger and bigger. Technically, there's a negative there. So even with that 0, I would be heading towards negative infinity, so it diverges. Okay, so even the telescoping, this one is just going to get bigger and bigger, so this one diverges. All right, let's try one more like this. How are we doing on time? Oh, we're doing great. Okay, so yeah, let's do one more, and then we'll stop it. And then part B will be pretty short. Okay, so let's do the summation as n equals 1 to infinity. We're going to do e to the 1 over n minus e to the 1 over n plus 1. Okay, what kind of gives it away that we're probably going to be doing telescoping? We got 2 things, and we're subtracting. Okay, and I think we can go right to it. So let's plug in a 1. Double color, here we go. Okay, we were going to plug in a 1. We get what? E to the first minus e to the 1/2. And then plus, we'll plug in a 2. E to the 1/2 minus e to the 1/3. That's my hand in the way. Hopefully we're doing okay. Plus, let's plug in a 3. What do we get? E to the 1/3 minus e to the 1/4. We're just taking a 3, plugging it in both of those. Plus, plug in a 4. So we get e to the 1/4 minus e to the 1/5. Let's go one more. I think that'll be plenty. 5. Switch it one more time. E to the 1/5. Oh gosh, that looks messy. Minus e to the 1/6. Yeah, I even took it out a little bit further. Yeah, okay, beautiful. Okay. All right, so negative, positive, gone. Negative, positive, gone. Okay, we get the idea. All right. So what do we have? We've got the limit as n approaches infinity of e to the first, so that's just e. We could write the 1 if we wanted, but that's just coming from here. That's just going to be e. And then technically this one eventually will cancel, so we just need the rule on that one. That last one will never go away. And the rule is this guy. So minus e to the 1 over n plus 1. Okay. All right, so what happens? What happens here is n gets bigger and bigger and bigger. This fraction is headed towards 0. So we've got, we don't have the limit, because as we plug in this number, this guy's going to stay e, And this is going to head to 0. Just this fraction, which is the exponent, is going to head to 0. Anything to the 0 power is 1, and so that's our value, that the sum would be approaching e minus 1. All right, let's stop there, and then we'll do just 3 other problems for part B.